Do you know, friends, Rakuten, the Japanese e-commerce giant, used LangChain's tool to quickly launch an internal AI platform that empowers employees. And it took just a few engineers about a week to build the initial system, benefiting thousands of staffs. So guys, with that, I welcome you to today's comprehensive tutorial on LangChain, which is a cutting-edge framework that's revolutionizing how we create intelligent applications with large language models. In this tutorial, we are going to learn from setting up your environment to building an AI app with LangChain. So whether you're a beginner or a developer looking to integrate LangChain into your projects, you are at the right place. Here's the agenda for today's session. First of all, we are going to discuss about what exactly is LangChain. Then we will discuss about prerequisites and the setup required to set your LangChain in VS Code. Then guys, we will deep dive into LangChain basics. After that, we are going to create a basic LangChain app. Then we will deep dive into RAG. After that guys, we will look into agents with LangChain. Now before we move on, just a quick info guys, Simplilearn has got applied generative AI specialization program in collaboration with Michigan Engineering Professional Education. You're going to learn to develop and deploy generative AI enabled applications. In this applied AI course, you're also going to learn applied generative AI course with hands-on training in agentic AI, LLM, and tools like OpenAI, LangChain, and Stable Diffusion. You're going to learn from industry experts to drive innovation, automation, and business growth with real-world AI applications. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now guys, before we start our session, here is a short quiz to test your knowledge. So the question is, what is LangChain primarily used for? And your options are A, building websites, B, building AI-powered applications with large language models, C, data storage and management, or D, game development. Please mention your answers in the comment section. So guys, let's get started. So guys, let us first try to understand what exactly is LangChain. Actually, LangChain is a framework that helps developers build applications powered by large language models. In simple words, it acts like a bridge between an LLM and the real task that you want your application to perform. Normally, if you use a model directly, you just give it a prompt and get a response. But real applications need much more than that. They need memory, documents, APIs, tools, databases, multiple steps, and decision making. And do you know, all of this is possible because of the help of LangChain, as it helps organize all of this. You can think of it like LLM is the brain, but LangChain is a system which tells that brain what to do, what information to use, what tool to call, and what to do next. For example, suppose you want to build a chatbot that can answer questions from your company's PDF files. The LLM alone cannot reliably do that unless the content is provided. LangChain helps you connect the model with those documents, retrieve the right information, and generate a proper answer. So guys, LangChain is not the language model itself, it is a framework that helps you build useful, structured, and real-world LLM applications. Now guys, you would be wondering why LangChain is important in the era of LLM apps. So guys, let me tell you, today many people are not just using LLMs for casual chatting. They are building serious products with them. And these products need to be more accurate, more useful, and more connected to outside data. And this is where LangChain becomes very much important. A basic LLM call works fine for simple tasks like summarization, rewriting, or generating text. But once you want your app to do something smarter, problems start appearing. Let me give you one case scenario. Let's say you want the model to remember previous conversation context. You may want it to search a document before answering. You may want it to use tools like calculator, web search, or with databases. And also, you want a workflow where one step feeds the another. You may also want an agent that can decide which action to take. And believe me guys, doing all of this manually becomes messy very quickly. LangChain gives you the structure to the whole process. It helps developers by offering ready-made components for prompts, document loading, retrieval, output parsing, memory chains, and agents. So instead of building everything from scratch, you can combine these pieces and create an intelligent workflow much faster. And that's why, guys, LangChain is becoming so popular in today's era because it is allowing you to move beyond just prompting, but also helping you to build a real application. Now, guys, I'll tell you one of the most common use case is document question answering system. Let me elaborate. Suppose, let's say there is a company which has hundreds of PDFs, policies, reports, or manuals. So instead of reading everything manually, you can build a system where user asks question in plain English and the application finds relevant content and answers it. Another example is customer support chatbot because this chatbot can answer product questions such as internal knowledge bases, it can remember user context, and it can even escalate when needed. You can also build a resume screening assistant also where it can read resumes, compare them against job description, summarize candidates and rank them based on fit. So LangChain is also useful for research assistant process. So these systems can gather information, summarize long content, compare sources and create structured outputs. Another powerful use case is an AI agent workflow. For example, a travel planner agent can understand a user request, search destination, suggest itineraries, and estimate budgets and organize output step by step. It can also be used for email drafting assistance, meeting note summarizers, also like SQL query generators and coding assistants. And it can also give you legal and financial advice by analyzing the document. So in a nutshell, if I have to say, LangChain is useful whenever you want an LLM to do more than just answering one prompt. Now, it's time for us to set up our LangChain. Before that, let us try to make sure that we have Python installed on our system, and we'll be using VS Code for this demonstration. You can use PyCharm also if you have. That's also amazing ID. So I'll show you where you can install. So first of all, type Python download, and it's a very simple process, guys. So this is the official website of Python. It says python.org. Just click on this and you can see the latest version is 3.14.3 and it's available for Windows, Linux, macOS, Android and many other. And when you click on this, so this is a Python install manager and just you can extract it and just follow the installation process. Let me show you guys. So let's say since I have already installed Python, guys, so whenever you open this, it's gonna give you the required steps for installing, and it's a very simple process. Just you need to select the required boxes. So that's one of the process. So make sure that you have Python installed on your system. Now you have two options, guys. Either you can use PyCharm. Okay, you can use a community version of PyCharm for the demonstration. So just go all over here. So you can see PyCharm is actually by JetBrains. So JetBrains is a company which had made PyCharm, and you can download it for Windows. You can download it for Mac OS also, since it actually identifies which operating system you are using. And for me, it's giving Windows. But if you're using Linux or Ubuntu, it's going to show you that. So download the community version for that. This is amazing IDE. Next, if you are not using PyCharm, I would suggest you downloading VS Code. So go all over here. So this is a Visual Studio Code. Click all over here, and from here you can directly download it. So guys, I have already downloaded VS Code in my system, so I not need to do that. Okay, now after installing Python, one of the most important thing that you need to do is you need to go to your respective command prompt and check if Python has been installed successfully or not. So for that purpose, what you need to check is the version of Python. So let's say -- Python 3 version. Since my version is 3.12, so I have to check with Python 3. So Python 3 will be my respective command for checking and running my program. So guys, after entering it, you can see it shows the version 3.12.5. Since I installed it pretty earlier, so I have a kind of older version, but this is also very much compatible. Now after this, guys, what you need to do is you need to create a folder. You can give it name as LangChain project and open this in VS Code. So you can see all over here, I have already opened it. Now, before that, what you need to do, guys, is very simple thing. First of all, create a virtual environment. So how do you create a virtual environment, guys? You have to give this command python 3 -m venv. Okay, so this is a respective command which creates your virtual environment. Now, if you want to refer the official documentation, you can also go all over here. So just type create virtual environment and type python doc. So you will be directed towards the official website of how to create a virtual environment. You can read this, guys. This is amazing source, and it's going to help you to understand what are the other things, other parameters to consider when you are creating virtual environment. So generally the command is this python -m venv, and then you give the given path all over here. So you can see we have a couple of other options also available, but we don't need to use that. So in this way, when you type this respective command, you can see there will be a folder created named venv. So this is the respective step. Now, after this, guys, what you need to do is you need to activate your respective virtual environment. Make sure to type this command venv-scripts-activate. Now, guys, there are a couple of other libraries that you need to install. For example, here we have OpenAI, and this will be used for integrating and connecting with OpenAI models like GPT 5.4 or GPT 5.2. Then we have FAISS, which we'll be using for vector search. Then we have ChromaDB, which will be used for storing and retrieving embeddings. Then we have tick token for token-based processing. Then we have PyPDF for loading the PDF documents. And if you want the web scrap or load the web content, we can use Beautiful Soup for. And finally, sentence transformers for other embedding libraries if required. Now, this is kind of a very brief idea. Let us dive pretty much in depth and try to understand what libraries we'll be installing. So first of all, we'll be installing LangChain. So the command is pip install LangChain. Now, why we have to install it? Because, guys, LangChain is a main framework which is going to help us build applications using large language model, and it is going to provide the core tools which will be required to create structured LLM workflows. So instead of directly calling a model and writing everything manually, LangChain will give you components like prompts, chains, agents, memory, and document loaders. Now, after this, you can see we have pip install LangChain OpenAI. So guys, why we are installing this? Because LangChain itself does not include model providers. Instead, it connects to different providers using integration libraries. So LangChain OpenAI is the integration between LangChain and OpenAI models. And this library is going to allow you to use models like GPT 5.2, GPT 4.0, or GPT 5.4. So that's why we need it. Next up we have is pip install OpenAI. So this is an official OpenAI Python SDK. It handles API communication, authentication, and also sending prompts. This is also going to help you to receive model responses. And LangChain internally uses this library to talk to OpenAI servers. So you'll find the flow something like this. First of all, let's say you have written any code, then it goes to the LangChain, then it goes to the OpenAI library, then it goes to OpenAPI server, and then your model response is happening. So this is a respective workflow which is exactly happening in our given program when we are using LangChain. Now, next thing we have environment library which is python.env. So why we need to install it? Because this library is going to help us manage environment variables and especially secrets like API keys. So instead of writing the API key directly into the code, we are going to store it in a .env file. And I'll show you. So this is also one of the way, but I've hard-coded the OpenAPI key and I'm loading it with OS library that we have in Python. So guys, next we are using is ChromaDB, and ChromaDB is a vector database which is used to store embeddings. Embeddings are basically the numerical representations of text which is used for semantic search. For example, if you build a system where users ask about PDFs, Then ChromaDB is going to help you by storing the document embeddings, searching similar text chunks, and sending relevant context to the LLM. And you would be aware about this technique. We call it as retrieval augmented generation, or RAG. Then we have something called as pip install fast CPU. So what is this library, guys? So FAISS is another vector search engine which is created by a company called as Meta. Now it performs very fast similarity search between embeddings. It is often used when we are building document search systems, AI assistants, or recommendation engines. It is faster for large data sets compared to many other vector search tools. Then we have TikToken. This is also a very important library. So why we are installing it, guys? Because the LLM is going to process the text in tokens, not in words. So TikToken helps count tokens and manage token limits. Now, why this matters? Because LLM have maximum token limits, guys, and exceeding limits causes errors. So token counting helps optimize prompts. And this library helps us with efficient prompt handling. So the simple architecture of this given setup would be, let's say you're writing any Python code, let's say an app.py file, then it goes to the LangChain framework. Underneath, it's going to use LangChain OpenAI integration, which is going to connect with the OpenAI SDK. And finally, it is going to call the API. Let's say I'm using 5.2 model. So it is going to go to this respective OpenAI model server. And after this, our model is going to give the required response based on the questions you have asked. So this was all about the setup of LangChain, guys. I hope so you would have got a brief idea regarding this. Now let's move on to the next part. Now guys, after this, what you need to do is you need to go to OpenAI API. So you can get your OpenAI API key from the OpenAI platform. Create your API key if you have not created it. Copy that API key, and you can have it all over here from this. You can see there is one option, create a new secret key. You can create it, copy the code, and then let's start doing some of it in our program. So guys, this is a simple LangChain setup what I did. So we'll be using OS library. I'm not using .env right now. So first, let us set our OpenAPI key. Then after that, guys, you need to import chat OpenAI from LangChain OpenAI and initialize a variable called LLM and use this chat OpenAI all over here. Now give two parameters, model and temperature. You can keep temperature as 0 for now, and for the model value, give it at 5.4. And let us create one more variable called as response all over here. And we are going to invoke this by saying explain LangChain in simple words. And finally, I'm trying to print response.content. So whatever the content will be given by the model, I will be printing those things. So that's what I'm trying to do all over here. Now, after you have done this, guys, all you need to do is you need to run your respective program all over here. So for running your program, since my file name is app.py, so I'm going to run Python 3. So since my version is Python 3.14, so I'll be using that, and just type your file name, which is app.py, and click enter. Now it will start executing based on the respective prompt that you have asked from the model. Let us wait for a couple of time, guys. So you can see we have got this respective output. So you can say it has given our answers to the LangChain. What exactly is LangChain? And you can see it's a toolkit for building apps that use LLMs like GPT. Then simple words it has explained. Then it has given something like it. You can think of it like as a brain. LangChain is a wiring that helps the brain talking to documents. Using external tools, keep track of the context and all of these things. So you can see we have successfully used LangChain with Python all over here. So I hope so, guys, you would have got a brief idea regarding the same. Now, guys, first let us try to understand what are chains. So in LangChain, you can understand chain as a sequence of steps where the output of one step becomes the input of the next step. So instead of sending a single prompt to the language model and getting a response, chains allows us to build structured workflows. You can think of it like an assembly line in a factory where each station is performing a specific task. And let's say as the result moves to the next station, similarly in LangChain, each step performs a task such as formatting a prompt, calling the model, or retrieving documents or processing the output. Imagine, guys, let's say you want to build a system that summarizes the document. So how this is going to look like? So this is going to look like something like this. First of all, let's say you have the respective user input, and let's say it goes to all the way here. It is going to load the document. Then after that, your document will be split up, and after that, you will send chunks to the model. After that, guys, you are going to generate the summary, and finally, you're going to get your final answer. Now, each of the steps is a part of the chain, and LangChain manages the flow between these steps such that the developers don't have to manually coordinate everything. Now, you would have got a brief idea regarding chains, guys, and also now you would be very much comfortable in understanding why chains are required, as they are very much useful when your task requires multiple processing stages rather than a single prompt. Now, let us try to understand some of the prompts and prompt templates. So, what is a prompt? Basically, a prompt is simply the instruction that you give to the large language model. It tells the model what to do and how to respond. For example, let's say if I ask to my model, let's say explain machine learning in simple steps, then this is a basic prompt. But however, in real application, prompts are often kind of dynamic. That means part of the prompt that changes depending on the user input. Now, this is where prompt templates become very useful. So guys, a prompt template allows us to create a reusable prompt with placeholder. Now, example could be something like this. Let's say if the user provides a topic equals to, let's say, vector databases. So the final prompt becomes explain the concept of vector databases in simple terms. So you basically declare, let's say, the topic value, okay, and let's say you put it up vector databases. And your prompt would become something like this: explain the concept of, let's say, vector databases in simple terms. Now, guys, this makes the system much more flexible because the same template can be reused for different inputs. So that's why prompt templates are very much important, and we will be using the same thing. Now, guys, let us move to the next part where we are going to explore RAG. Now, guys, let us try to understand what is RAG and why it's so powerful when we deal with LangChain. So, guys, RAG allows application to answer questions using external document. So, we have already discussed about vector stores like FAISS or ChromaDB, which are used to store embeddings, and they retrieve relevant chunks of the data. So, RAG is that's why very much important. Now, guys, let me show you the respective flow of RAG. So let's say we have a source document, or let's say data.txt, and we are going to load this document using Python, and then we are going to split the document into small text pieces, and we are going to create embeddings for each of the chunk. So embedding is nothing, it's just a vector format of storing the text, and as I've shown you, embeddings are in numbers. Then we are going to store that respective embeddings in vector database like FAISS or Chroma. And then let's say if the user asks a question, what is LangChain? We are going to create a question embedding for the same. Then we are going to do the similarity search in the vector database. And then we are going to retrieve the top matching chunks which suggest what exactly is LangChain. And then we are going to build final prompt context and plus question, and we're going to give it to the LLM like GPT 5.4, and then our answer would be shown. So this is how our retrieval augmented approach exactly look like when we are trying to build it up using LangChain. So in nutshell, whenever I talk about, let's say, retrieval augmented generation, it actually is has a very amazing application because it is going to give context to your respective question which you ask to the LLM, and it will search for any external documents or any external database. It's going to search the context what you are trying to do. Now let us try to do the hands-on for the same so that you will get more idea regarding the same. Now there are a couple of libraries that will be required. So we have already installed LangChain, LangChain OpenAI, and we can install LangChain Core OpenAI FAIS CPU, then tick token. Now we have so guys, we have mostly all the libraries installed earlier only. Now let us try to build the respective thing. Now guys, we'll create one more respective file. We will call it as data.txt, and let's say in this respective file, we have our respective thing where we are just giving some idea regarding RAG and LangChain. So something I have written all over here. Now this is an important file which will be taken into the context. Now what we need to do is we need to write our app.py. Now guys, here I have installed LangChain community version also. So it might take some time for it to install. Now guys, let us try to build our respective app.py file. And first of all, I would like to install OS because this is very much important in the context. Let's say whenever we are trying to add our OpenAI API key. Then you can see from LangChain OpenAI, I am importing chat OpenAI and OpenAI embeddings. From LangChain community.document loaders, I am generally loading the text loader. From LangChain -text splitter, I am importing character text splitter. Then from LangChain community.vector stores, I'm storing the vector DB, which is FAISS from Meta. And from LangChain core, I am importing this respective library chat prompt template. From LangChain core.output parsers, I am importing string output parser, which is going to parse our respective input. Now, first and foremost, let us set up our OpenAI key. So guys, in the first step, you need to set up your OpenAPI key. So for that, you can do os.environ and add your OpenAI key all over here. Then load your respective text document. So for that, create a variable called loader. And we are going to use text loader all over here, which we got from LangChain community.document. And it is going to load this respective data.txt file. And let's say the encoding I have given is UTF-8. And then create another variable called documents and call this loader to load the respective document all over here in this folder. So this we have done it. We have loaded our respective text document. Okay. Now next step, what we need to do is we need to split the document into the chunks for embedding purpose. So let us create a variable called as text splitter, and we are going to use character text splitter component all over here, which is coming from LangChain -text splitters, and this is going to split our respective text into chunks. So you can see I have given two parameters, chunk size let's say be 500 and let's say chunk overlap be 50. Now guys, let's say we have this respective paragraph all over here. Let's say I have written LangChain is a framework which is used to build application powered by large language models, and it allows developers to connect with LLMs with tools, memory and external data sources. Now all over here, if you see, if I've set to chunk size let's say 50 and let's say I give no overlap all over here. So chunk 1 would become something like this. Let's say LangChain is a framework which is used to build applications, and in the chunk 2 it is going to show you powered by large language model, it allows developers. Now there is no overlap all over here. Now let's say if you are saying, let's say we have the chunk overlap all over here, and then it could become something like this as LangChain is a framework which is used to build applications. then to build applications powered by large language model. And here you can see in the chunk 1 and chunk 2 there is overlap all over here. So that's what we were trying to do in our app.py. So we have given the chunk overlap parameter to 50. So there will be overlapping. And finally, we created one variable called doc, and we call this text splitter, which we have created all over here. And we call this method split documents all over here. Now, if you remember, for our respective thing, it is also coming from the LangChain.text splitters to help us perform the splitting thing when we are trying to do it with the document. Now it's important time for us, so we'll be using OpenAI embedding function to create the embeddings, and let us store in this variable called as embeddings. Then let us say we store the respective document in chunks in FAISS vector database. So you can create vector store all over here, and from this you can call FAISS.fromDocuments. You can pass docs, and then you can pass embeddings all over here. So from this you can store the documents in chunks in the vector databases. Finally, create a retriever all over here. So declare a variable. So now here you need to use vector store as a retriever, and let's say the search keyword argument is 3. Now guys, what I'm exactly trying to do all over here is that I am trying to create these embeddings into as respective chunks, and this chunk will be stored in the vector DB as FAISS, and then we are making this vector store as a retriever, and we want to return top 3 results from that vector database, such that it helps us to understand how we are processing the result based on the top 3 matching thing which we found in our vector DB. Now it's time for us to create a LLM. So declare a variable called LLM, and we can use chat OpenAI for the same, which is actually coming from this respective library, if you could see. So it is coming from LangChain OpenAI library all over here. And then give your model name, give your temperature, keep the temperature as 0, it's not required that much. Then we'll create a prompt template all over here, which is very much important. So as we discussed earlier, like how we are going to, we can attach this respective prompt template for our all the inputs which will be given by user, such that we could just add the topic and we could retrieve the respective result. So you can see it says you are a helpful assistant, use only the provided context to answer the question. If the answer is not in the context, I could not find that in the document. And let's say you give your context all over here. Let's say this is the question. Now let's say we'll start the question answer loop all over here. So let's say we're just trying to display that our RAG app is ready, and type exit to stop or to exit from the respective loop. Now it says while it's true, then you ask a question. Let's say we use an input function all over here, and you ask your respective question, and let's say if the question is in lowercase, exit, print goodbye, and break. Then what we are trying to do is we are trying to retrieve the relevant chunks. So we'll create a variable called retrieve docs, and we'll call retriever again, and we're going to pass this question all over here. Then we are going to join this context all over here with the join function, and this is the list comprehension which we are trying to do. So if doc in the page content is present for any, let's say for doc in the retrieve docs, so we are going to build a chain for that purpose. So here we are storing the respective context all over here, okay, and then we are calling the join function to actually join that respective context. Now it's time for us to build a chain. So create a variable called chain all over here, and chain equals to prompt or LLM, or we could pass it as string output parser. Then after that, we are trying to get a response. So response equals to chain.invoke. First, we are going to invoke the context. Then we are going to invoke the question. And finally, we are trying to print the answer. And then we are trying to print the respective response. So this is the given thing, guys. Let us try to run our program, and let's see what is our respected output. Now we'll type Python 3 app.py and let's try to run this respective program. And you can see it is saying ask the question. Let's say if I just say explain what is RAG. So let's try to see all over here. Now you can see it's trying to give us the respective answer all over here, and it says RAG stands for retrieval augmented generation. It allows application to answer the respective thing. Now let's say if I ask this question, which model is better, GPT 4o mini or GPT 5.4? Now let us try to see. So you can see I have not provided this reference in our document. So you can see it says I could not find it. So this is one of the wonderful applications of RAG. So what exactly we did was we are feeding the data to our model and look for context and then try to get the respective output. So this was one of the demonstrations of RAG application, guys, and you would have got the idea for this. Now guys, let me explain you once more from this respective step where we were trying to create the embeddings. Now, when I say embeddings equals to OpenAI embeddings, what we are trying to do is we are trying to convert text chunks into vector embeddings. And embeddings represents text as numbers all over here. So for example, let's say if I write LangChain is a let's say is a framework all over here. So it might be stored in the embedding format as vectors, something like this. Let's say this might become 0.23, this might become minus of 0.91 and 0.44 and so on and so forth. So basically these vectors capture the meaning of the text, and this allows the system to search based on semantic similarity, not on exact words. And after that, you would have got a brief idea that we tried to create our vector store. So for creating the vector store, what we did was we actually created FAISS, which is a vector store all over here, and dot from document embeddings. Now we are storing the embeddings in FAISS, okay, vector store, which acts like a database for all these vectors. So this means that, guys, for example, all over here, so let's say we have the respective document chunk, and let's say this goes to the embedding, and let's say this goes to the context which is stored in FAISS vector DB. Okay. So later, let's say when a user asks this questions, so FAISS finds the most similar chunk, and this is a search engine of the RAG system. Now, this was one of the most important steps. So if you would have missed out, I re-repeated it. Now, if I discuss from the retriever context, the retriever is a component that searches the vector database. Now, when we say k equals to 3 all over here, we are saying that the retriever is going to return the top 3 or the most relevant document in the chunks. So let's say when the user asks the question, for example, what is LangChain, the retriever searches the vector database and returns the most relevant chunks. Now finally, we have created the large language model all over here with the LLM, and we have called chat OpenAI for the same, and model I'm using 5.4 and temperature 0. So here, this is one of the most important steps, because here we have to define the LLM that is going to generate our final answer, and the OpenAI model is used to generate the responses. Now we have discussed a lot about temperature. What does a temperature do, guys? Temperature actually controls the randomness. So 0, if we give it, so it tells you one of the more factual answers. If you give 1, it is going to give you more creative answers. So for RAG systems, we usually keep it to low so that we can reduce the hallucinations. And finally, guys, here at this step, we created a prompt template. Let's say I've given something like you are a helpful assistant, and if the answer is not in the context, I could not find your document, like I showed you in the output when I asked you which model is better. So after giving the context and the question in this respective thing. So this is a prompt which is instructing the model how to behave. It includes two placeholders that we discussed. One was context, one was question, and the context will contain retrieved document chunks. Question will contain the user query. And after the final prompt is sent to the model for to understand the context and answer it. So guys, here the context could be something like this. Let's say LangChain is a framework which is used to build a application by building large language models. So let's say if I just put this as context all over here. Okay. Now the next thing, if someone asks the question something like this, so we can take up the next value all over here. And a question somebody could ask, let's say, what is LangChain? So this is how we are having two placeholders all over here. Now, while creating our respective question and answer thing, we have got the respective idea all over here. That first we are asking and uh, to input the respective question all over here. So this allows the user basically to ask questions continuously, and the loop will keep on running until the user types exit. Now we have to retrieve the relevant chunks all over here. And for this, we need a retriever component. And this is step, it is going to search the vector database. The question will be converted into an embedding, and it is going to come compared with the stored document in the vectors. Now, FAISS returns the most similar chunks all over here. Then we created a context all over here. Let's say context equals to context, and after this, this context is actually retrieved from the respective, all over here from the question. And so we combine the retrieved chunks into a single block of text, and this becomes the context which is sent to the large language model. For example, guys, let's say here we wrote, like, let's say LangChain is a respective framework which is used to build applications, let's say powered by large language models. So RAG, and here you can see what I'm telling a bit about RAG all over here. Now, in this, we are giving example of the context all over here, and this is getting retrieved here. Now, finally, after this, what we are trying to do is we're trying to build a LangChain pipeline. So you can see here we have built the LangChain pipeline where I have given chain equals to prompt, and it goes to the respective LLM, and then it goes out to the respective output parser. So something like this you can consider. This is our LangChain pipeline, guys. So let's say prompt goes to let's say LLM, and then it goes to our respective output parser. So this is a respective pipeline that we are having, and this parser converts the response into the text. Pretty interesting, guys. Now finally, we are trying to generate an answer. So we are creating a variable called response, and we asked our respective chain to invoke the context and based on the respective question. So here we are sending the values for the placeholder. So context is retrieved from the document chunks, and the question is retrieved from the user input. And LangChain insert these values into the prompt and sends the final request to the model. And finally, we print the respective result all over here. So this model generates the final answer using the retrieved document context. And this was a sample project we did where we are trying to return, let's say from our respective document all over here, and trying to feed it into the model to give us the required context. Now, I'll also show you how the entire RAG workflow is exactly working, guys. So let's have a one good revision because this is very, very much important. So let's say for first of all, in this given project, what we did was, like, first say we got the user question. Now, user question got forwarded all the way there to, the question got converted into embeddings. Then after that, we were trying to search the vector DB. Now, after this, what we did was we retrieved the respective chunks, okay, or relevant document chunks, and we inserted the chunks into prompt. And finally, we had sent these prompts to the LLM. And finally, your answer was generated. So, guys, this is our respective workflow that we created in this project, and this was done using LangChain. Pretty interesting, guys. I would also request you to explore the LangChain official documentation. Try to explore much more things. So, guys, now let us discuss a bit about agents. Now, what does an agent do is they combine language models with tools, and after that you can ask them questions and they're going to reason about it and give the answer accordingly. Now let me show you the flow how an LLM agent runs. Suppose, let's say you give an input to the given LLM model, and then it goes to the mode, and mode has three things. First is action, observation, and finish. So first, the mode goes to the action and it goes to the tools. It tries to process it. It does the observation part and it goes back all over here at this stage. And after that, you are given the respective output by the given model which you are using it. So this is the respective thing, or you can consider the flow of creating an agent or how an agent is exactly working. Now, you can see there's a one important thing written all over here. It says the create agent methods from LangChain is building a graph-based runtime, and it underneath it's using LangGraph. Now that's pretty interesting about it. Now let us discuss what are the core components of this. First one is model. So model is your reasoning engine. Then under the model, you have something called as static models. For example, you can configure it once and create the agent, and it can remain unchanged throughout its execution. For example, you can type import create agent from LangChain, and then you declare a variable agent, and this language looks like somewhat like kind of a JavaScript, where you are basically creating an object of create agent all over here. So with key and value pairs all over here. So you can give your model name. Let's say if you are using GPT-5, you can give GPT-5 all over here. Then there are certain other parameters also. So we had discussed last time about temperature, what is the maximum token, timeout. Okay. So similarly, you can add more parameters all over here. And finally, then you can create your respective agent with the create agent method. So first create the model with the chat OpenAI, so which is coming from LangChain-OpenAI, and create agent is coming from LangChain. So guys, this is somewhat a very brief idea how you can start working with the respective agents. So guys, I hope so in today's tutorial you would have got a brief idea regarding LangChain, what it could do. So guys, thank you very much for watching this video. If you have any doubt, then please comment in our comment box and our team of experts will get back to you. And also guys, do not forget to hit the subscribe button and click the notification bell icon such that you don't miss out any update regarding any new tools or any tutorials from Simplilearn.